Hello there. In today's episode, we're going to talk about using Magic's Single User Edition that allows solo developers or developers building side projects to design, build, and deploy single user Magic applications without a development license, and crucially, also without a runtime license. That's free of charge. This can be used for freeware, shareware, and commercial applications. There are restrictions, of course. You can't use Btrieve, Pervasive, ODBC, or SQL Server gateways. Your only database choices, in fact, are SQLite, memory, and in the latest version of XPA, also JSON. The Magic application itself can only be used by a single user for each install, but that still gives huge opportunity and potential for the Magic developer community. That's you and me. A further limitation that I've seen is that it appears not to work on some foreign Windows locales, such as Japanese, or under Docker. For that, you'll still need a regular enterprise license. In this video, I'll cover some background, a feature comparison, and a setup of Single User Edition, and then show a couple of MathStack related demos. Now, if you're watching this, chances are you already know how to build desktop applications with Magic. Since this is me, and I'm all about the integration opportunities, we're going to go a bit left field, showing how we can leverage Magic Single User Edition as backend to a local web app, integrating with Python and FastAPI, served with Uvicorn, which is a web server for Python. I'll show you a quick demo of a Kanban application that's running in the browser that I built with Python, Sqlite, Tailwind, and HTMX. And then, after a little bit of a code walkthrough of what's going on, we'll throw Magic Single User Edition into the mix as an alternate backend that slides in with the same capabilities, working with the same database. The code and notes for this episode are in the Magic Polyglot GitHub repository in the EP8 folder. I've included some links in the notes for a couple of pages and articles on Single User Edition, which was introduced way back in 2011, first called Unipath Jet. It was a grassroots attempt to seed the developer and enthusiast market and create a pipeline to onboard new developers. Now, we can debate how successful it's been, but certainly Magic are still around and still generating great annual revenue. But this is about us. I've linked to the original press release and a FAQ with some background explaining single user's purpose and use. There's a link to the page on Magic's site where you can download a free single user install, which I think is still based on XPA 4.8. And there's another link to the product comparison chart that details what is and isn't available in the single user version. Finally, if you have legitimate access to the Magic download site, you can get the latest full install, currently XPA 4.10, and use that to set up Single User Edition with the latest XPA features. So let's set about taking a regular Magic install and making it Single User Edition. If you navigate to where you have Magic installed, in my case it's in a directory called XPA 410, we'll make a few minor changes to the Magic INI. For Magic Single User mode in Magic INI, we'll remove the license name and license file lines. Actually just comment them out with a leading semicolon. Likewise, because Single User Edition only supports the SQLite gateway, we'll comment out the other database gateways to avoid nagging startup dialogues. You can see what I have amended about the Magic Gateway section of the Magic INI. You can manage this with a separate INI or with INI overrides, so that you can still run side by side with a licensed version. Now if you run Magic and access the Help About dialog, you can see we're running license-free as single user edition. It's worth mentioning that the application ECF cabinets you'll eventually build and deploy in this mode are 100% compatible with the regular Magic licensed versions too. Now, if you already downloaded the episode materials, you'll find an mg-su folder that contains the Magic application we'll look at a bit later. For me, this is in C, Dev, Magic-Polyglot, EP8, mg-su, and you're opening mg-su, su standing for Single User Edition, .edp. In there, you'll see a single task database table that's Sqlite and a few programs in the repository. Let's minimize Magic for now, and we'll get our Python development environment set up. So if you navigate back to the EP8 folder, you'll find a file called notes.txt. Let's open that. This contains step-by-step instructions we'll use to get things set up. Now, let's also open a command prompt, and we'll change to the same EP8 folder and get started. We'll use python-m venv to create an environment. And then activate it with activate.bat. Next, we'll install the packages we need. FastAPI and UVcorn. Now we're being prompted to update our version of pip. Not entirely necessary here, but okay, let's just go ahead. Next, we'll install SQL model. And we'll check python.env is installed. Now, Jinja2 is a great templating framework, not unlike Magic's HTML merge tags. And finally, Python-multipart for some form handling. A useful command I've listed here just allows us to confirm which Python environment is currently active. We don't really need it right now, but if we're knee-deep in multiple Visual Code terminals, it can be a ready reckoner. Alright, let's launch Visual Studio Code in this folder by typing code space dot. Depending on your Visual Studio Code settings, the environment might be automatically selected. Otherwise, just activate it at the terminal prompt. As I said, at this point, I'm assuming that you've already downloaded or cloned the Git repository. We can see 4 folders: env, the Python environment; mg-su, the Magic application folder; Python, where our web app lives; and static, which contains the images, CSS, and the JavaScript bundle served by our web server. Let's finally see the first demo. Change directory to Python and execute py space main.py to start up our web server. Okay, good. You can see that it's running on port 8000. So we'll go to a browser and access localhost, which is 127.0.0.1:8000. And our entry point for the application demo is Kanban. Boom. So we have a basic Kanban board with tasks that we can create, track, update, and drag between status columns, perhaps later delete. Not all the functionality is complete, and I'm going to set you a challenge on that later. But this is just a demo, and I set a time limit of getting this done today before Thanksgiving. So what you see is what you get. Let's see some action. We can edit tasks and see the details. Although very little here is implemented, you can't yet post comments or add attachments and photos, while save only acts as close. The only working button is archive, which in fact I've made a delete for now. We can press it and see the task vanish from the list. We can drag and drop cards between columns. And we can press the Add Another Card button to add a new task and see it appear in the list. Let's add another. And finally, for now, if we drag a card into Done column, we can see that the status text updates to Done automatically. Before we get to the magic part, let's have a quick walkthrough of the Python code that we're using here. This might not be for everyone, so if you do want to skip ahead to the magic part, maybe it's around 10 minutes. First, let's look at the .env file. These are just environment variables used by the application. You can think of them as Python's logical names. So I've got a definition for where the magic requester lives, and also the path to the Sqlite file that we'll share between the Python and Magic projects. Main.py is the entry point for the Python application, and it not only defines and imports all the packages that we installed previously, but also some of the modules that I've created. So we load the env file, and we define where the SQLite database lives, and we create an engine to actually access it. We have a context manager that manages the application lifespan, that actually creates that database and tables. Then we instantiate the FastAPI application. Models.py defines the single table that we're using, task. You can think of this as like the magic data repository. Templates defines where the Ginger 2 merge templates actually live, along with some functions that we'll use as part of the merge process. Forgive me for describing a Python program as if it's a magic program. You can see that we have a few HTML templates. Prime among those is Kanban.html. But we also have others to display the edit task dialog and also to display the card itself, the task itself within the list. For example, you can see here the HTMX attributes on a button that will display the edit dialog for any given task. I spoke about the filter functions that are kind of in-process transformation to data during the merge process. You can see a couple that I created here. For example, with just a demo, the status text is hard-coded to either say it's done when the status is 3 or otherwise 3 days left. Clearly in production, we need a much more complicated set of functions there. The static folder contains the images, JavaScript, and CSS that we're using. I've actually used Webpack to bundle these. A little bit beyond the scope of this video. I might cover that in a future video. FastAPI allows us to very easily define and decorate routes in the application and specify which HTTP verbs we respond to for each. Here, the main entry point is a get on the Kanban route, and you can see it's just simply a call to a function build page. Now, build page is a function where I've hard-coded the column names just for illustration to do in progress done. We create a session and retrieve all the records in the task table. And then we do Python's version of the merge process, which takes the request and tasks and those list names and populates appropriately the merge template Kanban.html. Let's have a look at Kanban.html. To refresh your memory, let's just have a look at how the page is rendered. Okay, so we have a fairly straightforward HTML page that has a Tailwind markup, that has a reference to the HTMX script, a little bit of JavaScript to handle card moves that we'll see later. Divs, lots of divs. Nothing too intimidating. But what's interesting is that here we can see the Jinja 2 markup that's equivalent to Magic's MG repeat, MG if, MG else, and the MG variables that are embedded in a Magic template. Basically, anything in a set of braces or a double brace is equivalent to the exclamation mark $MG underscore that you're already familiar with HTML merge. Here's another example of HTMX attribute markup. And to make it real, that's triggered in the page by clicking on the edit icon for any given task card. Here are more examples of data from the task table embedded in HTML. And here is an example of how the filter function status text transforms the task status to appear as text in the page. Here's the add another card feature, which also tracks which column is going to be dynamically added to. This section we're looking at defines the HTML for the edit task dialog. And on the archive button, we have the HTMX attributes that handle the task delete. Now here's some more HTMX goodness, and we can see in the add card modal, we have a post, which also has an hxfiles attribute where we use JavaScript to gather the fields that we need to actually create a new card. That's a very powerful feature. Now, I said this was only a demo. So here's one thing I'm doing, which is not so elegant. This hx on after request is kind of like a brute force refresh of the page just to make things work quickly. It's not what we'd want to take to production, but for the demo, it works here and now. And here back in main.py is the endpoint for that post to Kanban to actually create a new task. And we can see that we retrieve the fields we need from the form submission. We go off and call a helper function called create task, set up a session, add the task, commit it, refresh, and then build the card, the task that we're going to return to be embedded at the end of the column list. And there's a function build task that simply builds that HTML. Task card.html is the fragment that we use to do that. And again, back in Kanban HTML, we have hxSwap, hxTarget attributes that determine where that new card is going to be placed in the page. So now that you're armed with all that back-end information, if we come back to the page and we go through an add card or an edit card cycle, hopefully everything just makes sense. To paraphrase Neo from The Matrix, suddenly you know HTMX Kung Fu. So again, you can see that the markup in the Kanban.html file for the Jinja 2 templating really resembles what goes on with Magic HTML merge. There's nothing new under the sun. As an example of another route within the main.py Python file, we can see here how we handle returning the edit dialog for any given task. We start a session, we retrieve the task information, and then we render that within a template response using the edit task dialog HTML, where we insert the task data. Again, we can see here the HX attributes that are defined on the archive or delete button. And we can step through the root and main.py that actually handles that delete request. One more time, let's see it work in the front end now that you know what's going on in the back end. So I don't mean to be deliberately controversial, but from a certain point of view, you can see that maybe building a web application in Python is easier, faster, cheaper than Magic. I'll let you make your own determination. Okay, let's see what happens when we do throw Magic into the mix. So back in Magic, we have a single table defined in the data repository. It is the task table that we used in the Python application. So it's the same database, same table name. I actually used getDefinition to retrieve the structure. We can browse it and we can see exactly the same data. With limited time tonight before Thanksgiving, all I'm going to do is replicate what we had in Python for the main Kanban display task and see it work in Magic. So we have a single program, and that's a parent-child set of tasks. And rather like we had in Python, where we had a for loop for each of the column headers, and then a loop within that for each of the tasks, the parent task handles the columns, the child task loops through and displays all the tasks for that category. A pair of nested MG repeat blocks for the parent and child here allow us to merge that data. Let's put Magic into runtime mode so we can see it run. Now, very quickly, we'll take a look at the HTML template that Magic is using here. So basically, I took a copy of the Kanban.html that Python used, renamed it as mgkanban.html, and changed the Jinja2 template mechanism to the Magic HTML merge template and tags that you're familiar with. So as I described earlier, we have nested MG repeat blocks, and we have Magic tags to merge in the data that Magic retrieves from the Sqlite task table. So what's interesting is all of the other endpoints, the edit, the add, the delete, the drag, they're all still referencing endpoints in Python. So we have a truly hybrid system, and you can mix and match based on what's appropriate. Okay, enough talk. Let's see the magic version in action. Now, the sidebar menu has a magic Kanban option as well. Let's access that. You can see we have a different route in the address bar, yet this page coming from Magic renders exactly the same. Now, in fact, the Magic Kanban route is still being handled by Python in main.py. However, that is just simply a pass-through function which calls the Magic requester to get back the page HTML. Let's see how that works. You can see there are a few functions and endpoints here that utilize a function that I wrote called callMagic, where we pass the app name, the program name, optionally also pass in variables, parameters that the Magic program needs, so that we can return whatever Magic passes back through to the browser. Now, callMagic in the mgutils.py file that I created simply wraps a call to the MG requester. Now, in production with an enterprise license, we wouldn't necessarily call the command line requester. We would probably set up some Magic microservice. However, when we're using the Magic single user edition like here, and we work in localhost, this is perfect. It's just rock solid. So let's see this Magic hybrid application work exactly the same as before. We can edit a task, delete a task, add a task. All of that looks good to me. What do you think? That's all I have for you today. But here's my challenge to you. Can you take the application and replicate all the functionality you've seen in a Magic-only web application? Can you develop it further and take it to a fully fledged Trello killer Kanban application? Can you package it and distribute it to the community for fun and profit? Now, maybe I'll circle back to this in another episode and do all of that, but can you get there first? Now, if you want further merit points, how about checking out the further study items? Take a look at Terso. Now, that's a cloud replication solution for Sqlite that will let you have multiple disparate single-user instances with Sqlite databases and synchronize all that data on an edge database in the cloud. You can have local disk access speed for read and writes, but still replicate to a central location. Have a look at Enigma VirtualBox, which will let you package a Magic Single User Edition runtime installed in a virtualized environment. That means a single executable. Now, Studio won't work, but runtime will. Finally, if you want the power and flexibility of a wrapped browser or kiosk-style app, you can think of something like Electron. You can look at a Python package called PyWebView. Okay, that's all I have for you. Happy Thanksgiving.